Hello, good evening, and welcome back for a new topic, new chapter. This is a very important topic because there is a lot of information in this which will be useful for studying oxidation reduction reactions, and also large most of the reactions we will try to study in terms of oxidation and reduction. These are very important things, students, that we are familiar with students redox processes. Already know we already know students what is oxidation. We are aware of what is oxidation, what is reduction in chemistry. Tell me, are you aware of oxidation and reduction in chemistry, students? This is very important.
Yes,
We are
sir.
studying what is oxidation, student. What definition?
Oxidation is gain of oxygen or
Okay, you are saying gain or addition of oxygen.
and reduction is the opposite. It is the
Of oxygen or removal of hydrogen, you are saying?
yes, sir.
Removal of hydrogen. These are old definitions which we have been using. And reduction, you are saying, is a
Loss or subtraction of oxygen
loss of oxygen,
or addition of hydrogen.
or you are saying gain of hydrogen. Thank you very much for helping me, students. You are aware of these things. Oxidation reduction is a very common thing in chemistry. When you do the reactions, you are aware of it. That if you have take magnesium, student, and you ignite the magnesium in oxygen, heat the strip of magnesium in oxygen, what happens is you are seeing magnesium oxide is formed. If I balance it, so this is example where magnesium has been oxidized. You are saying magnesium is oxidized here. Yes.
Yes, sir.
And if you are saying, okay, sir, we have copper oxide and you heat it with hydrogen, then what happens? You get copper. So here what there is a removal of the oxygen, student. You are saying that copper oxide has been reduced. That means these concepts are already known to a student, and whenever chemical reaction take place, you know what happens when new compounds are being formed. So there could be change in color, there could be change in state, there could be some heat evolution, or there could be, we already know when a chemical reaction is taking place, the new products are being formed. So this concept is already known to us, students. For example, if I consider a reaction CH3 CH2OH, students, what is this? What is this? What is the name of this compound, students? What is this compound in?
CS3, CS2OH,
You have studied in organic, students.
ethane? No, ethanol. Ethanol.
Ethanol is the correct answer given by you, sir. Students, very good. If I say that this ethanol is oxidized, do you know there are so many ways of oxidizing ethanol? Who are using some organic oxidizing agents in the organic chemistry for the oxidation of the alcohols? You have learned this reaction. So what you are getting, CH3C H double bond O, and H2O. So what has happened to this? You have seen what is the story here. You had CH3, CH2, you had OH, student. Then what is the happening here? You have lost these two hydrogens. One hydrogen from here, one, and this goes with the oxygen. So you are saying that alcohol has been oxidized. This is an example where you have converted ethanol into, what is the name of this compound, students?
Mm,
This is an aldehyde, ethanol.
ethanol.
So is an example of the oxidation. This is an example of the oxidation of ethanol. Yes or no?
Sir.
So that means you are familiar with the concept of oxidation. You are familiar with the concept of oxidation, where oxygen has been added And for example, if I write a reaction in the organic chemistry students, what is the name of this compound student? What is the name of this compound?
NO2.
When you do, you add tin and HCl and heat it. What is happen, student? What you are getting? What is happening, student? So
Reduction.
reduction is taking place here. Reduction is taking place. If I write it like this, and you have H2O. So what has happened here, student? This compound has been reduced. There is a reduction of NO2 group. Yes or no?
Yes, sir.
Okay, that means we are familiar with oxidation and reduction. Now the question is, these definitions which we have given, these reactions are very limited. Then what is not limited, or what we are using in the chemistry students? We are using more of what we are talking of electronic definition of oxidation and reduction. Now coming to the electronic definition which will be used by us. And an electronic definition, can you tell me, student, what is oxidation?
Oxidation is addition of electrons.
No. Oxidation is loss of electrons.
Okay,
Student,
loss of
always.
electrons.
Oxidation is loss of electrons. There is a loss of electron. If I say zinc undergoes oxidation, that means you are talking of loss of electron,
Using H
loss
minus 9.
in student. This is a loss of the electrons. Oxidation is loss of the electrons. And what is reduction, students?
Reduction is gain of electrons.
Gain of electrons. This was just to give a revision of the revision that yes, we can define the oxidation in terms of, for example, if you have copper 2 plus, it can gain electron, students, and what can happen. This is an example of reduction reaction. I hope these things are very clear to us, that we have shown you what is the definition of oxidation, what is the definition of reduction, and we will be using this electronic definition, students. But one thing is clear, that the oxidation means that this is losing the electron, losing the electron. Reduction means gain of electron. But these two things have to happen simultaneously, student. It is not possible that oxidation will take place. There has to be something to accept the electrons. What we are saying, the oxidation and reduction must take place together, student. It is not possible that you will have an individual oxidation. If oxidation is taking place, there will be reduction also taking place. So what we are saying, that this is what we call as a redox process. Now we are coming to the redox process. Redox process I have written here. This is the topic. Redox process means that in the reaction, what is happening, students? In the reaction, oxidation and reduction both are taking place. It is not possible that oxidation takes place, but without reduction, oxidation cannot take place. So redox reaction, redox process means oxidation and reduction takes place in a reaction. So whenever we will say that any reaction, you have seen, you have heard in electrochemistry, we have talked about the galvanic cells, and Daniel cell. You are aware of that. What happens, student? That if consider this, if there is a solution of copper sulfate, student, copper sulfate aqueous solution is there. If you add zinc in this is a zinc piece. Then what happens? What happens if you put a piece of a zinc rod in copper sulfate solution? This is a blue in color. You will find the blue color disappear slowly, and zinc start reacting. Zinc starts consumed. Zinc is consumed, and slowly the zinc will be consumed, and the blue color will be decolorized. What we are trying to say? What happened here? What happens here, student? You added zinc. This is a zinc rod, student, and you have copper sulfate, students. This is aqueous. This is blue in color, student. This is blue in color. And what happened? Zinc sulfate. This is white in color, and you got copper. So here you see that there are two things. There are two substances. Zinc is converted into zinc sulfate, and copper sulfate is converted into copper. So here what we are saying that students in this reaction, if I write in terms of the electrons, if I write in terms of the electron, these are the what I wrote. So actually this reaction can be split in two parts, there are two half equations. This reaction can be written as half two half equations. What are those two half equations, students? One is this one, second is this one. So in this reaction, what is happening? Can you tell me, student, which is being oxidized and which is being reduced in this reaction? What is being oxidized and what is being reduced? What is being oxidized in this? Tell me. Zinc, whether zinc is being oxidized or reduced, student, tell me.
Here, zinc is being Zn plus CuSO4. It is being.
I have represented two half reactions for this.
Okay.
And two.
It is being reduced and.
How is the zinc is being reduced? I have written.
So in which one?
Whether you write this or this, they are the same things. This I have written in two parts. I have said this reaction can be written as two half equations. What is the meaning of this? This is 2 plus.
It's neither being reduced and neither being oxidized.
Who said that? Zinc is being oxidized.
Oh, it's being oxidized, sorry.
Half reaction is this one, student. Zinc, here there was copper 2 plus.
Zinc is being oxidized.
Zinc is 0, this copper is 0. We will tell you what is this. These are called the oxidation number. We will explain to you just now what are these numbers, how to calculate these numbers. So here you can say that zinc is being oxidized. What is happening to zinc has been oxidized to Zn2 plus and copper 2 plus, this copper 2 plus it has been reduced to, students, copper. Therefore, you can say that in these reactions, oxidation and reduction are occurring together. But we are saying such reactions are called redox reactions, students. Such reactions are called redox reactions. This is an example of, students, what example I am giving you? Redox reactions. Means reduction and oxidation are taking place in the same reaction. Sir. Any doubt?
Sir. No, sir.
You have noted down, then I will proceed further. If you have noted down, I will drop this and will proceed further. So here I am talking of that there are these reactions are called a redox reaction, student, redox reaction. And in the redox reaction, as you can see, there are two things. One is oxidation, other is reduction. One species is being oxidized, other is reduced, and the two must be present. Two must be present, student, if we want to see there is an oxidation and reduction. It is not possible there will be oxidation without reduction. That's what we are trying to say, that these reactions involve two substances. One is oxidized and other is reduced. One gives the electron and other takes the electron. That is the story of a redox reaction. After you note it down, let me know so that I can drop this, student.
Yes, sir, I can drop it.
All right, student. Thank you very much. I hope you have understood our idea, what we are studying, student, what we are studying. In case of any doubt, you can stop me. Student, it is a very important topic and will be used, is going to be used, student, a lot. Now we are going to come to the second point which we have written on the board. First thing was what is an oxidation, what is a reduction, what is a redox reaction. And you have seen that in a reaction, both oxidation and reduction are taking place. Such reactions are called redox reactions. So we understood that point very clearly, students.
Yes, sir.
Okay, thank you very much for saying yes. Keep on interacting. This is something to be learned. Student, chemistry is very important subject and it should be learned, student. There is nothing to cram. We must learn chemistry. We must love chemistry. We like chemistry. I hope you are subscribing our YouTube channel where large number of videos are coming, where we are talking directly, solving the questions of the student and decoding your all the books of the chemistry. So your chemistry book will be decoded so that you understand what we are doing. And once you understand, then it is more easy for us students. Now you can see that these reactions were those where I could make it up that one is losing electron, other is gaining electron. In certain reaction, it will become difficult for us to know which is losing electron and which is gaining electron. Then what we will do in such cases, student? So the second part of this is we are going to talk about oxidation number. What we are going to talk is oxidation number, student. So we have defined an oxidation state or oxidation number in order to find in a reaction which is being oxidized, which is being reduced, and which acts as an oxidizing agent, which acts as a reducing agent, student. The substance oxidized is acting as a reducing agent, and the substance which is reduced acts as an oxidizing agent. If I am gaining the electron, if something is gaining the electron, it is reduced and then it is oxidizing the other substance. So
Yes, sir.
this is, we are going to study these redox reaction and important points about the oxidation number, students. We are coming to that point now. Oxidation number. Be comfortable while you are taking classes. We student, there is no tension, there is no pressure. We go slowly and slowly so that we learn everything. Any doubt is there, we will stop and explain to you. So by now you are saying that, sir, in a reaction like what we told you, we have oxidation and reduction taking place together. One is losing the electron, one substance is one element or one substance is losing the electron, other element is gaining the electron, and these reactions are called redox reactions. But there is a difficulty to observe the transfer of electron, that where the electrons are going. For example, consider if I write this reaction, student, PCl3 plus Cl2 goes to PCl5. Now in this reaction, how do we say that which is being oxidized and which is being reduced? So in such cases, what we talk is, we have shown here oxidation number, or we are talking of oxidation states. Oxidation states. So the idea was given in order to find out in the given reaction whether the substance is being oxidized and reduced by using the concept of oxidation number. And in all the compounds, we consider that we regard all. In this case, we are saying oxidation number or oxidation state. Student, I am saying we will consider that all compounds are ion. We say that all compounds are ion. So first thing we are saying all compounds are ion. Okay? And what will happen? If I consider an covalent compound is formed by the sharing of electrons. You already know about that. If there is a covalent compound, student, supposing there is a covalent compound, we say that it is ionic. We are saying it is ionic. For example, if I write HCl, supposing, which is more electronegative out of the two students?
Can
Tell me,
you
which
pardon,
is,
sir?
out of the two, which is more electronegative?
Between H and Cl?
Yes,
Mm,
it's a
H.
covalent compound. And now I will talking of oxidation number, where I will give you certain rules for finding the oxidation number. In this case, I am saying that we will assume this is an ionic compound and more electronegative element will take the electrons. Cl is more electronegative. Here, hydrogen is less electronegative. So I will say that the electrons, I will consider it ionic, and then I say, okay, the hydrogen is +1 and Cl is -1. So that means electrons have gone to the more electronegative element. In these compounds, we are saying the compound which is the element which is more electronegative, we give electrons to that element. Okay? So, and then we assign certain numbers which we are calling as oxidation numbers. So this will allow us to understand redox processes more easily. Why we are doing this? We are talking of oxidation number, students, to understand redox reactions. Otherwise it will be difficult for us. So for example, in this reaction we want to understand what is being oxidized, what is being reduced. So we are using the idea of oxidation number. So there are certain rules which have been given for the oxidation number. Rules. These rules we must learn, students, before we start answering the question. Rules means we have to learn them. And we are saying the first rule which I am saying is, the first rule is, we are saying treat the compound as totally ionic. Treat the compound as totally ionic. Okay? First rule I am saying, treat the compound as completely ionic. And then charges, then if the compound is ionic, there will be charges on the atoms. There will be charges. Yes or no? Just tell me. If
Yes, sir.
something is ionic, student, there will be charge on the ion. The
Yes, sir.
charges on the ion, are the oxidation number. Are the oxidation number of that element. Charges on the, it will be the oxidation number. For example, if I say KCl, okay, I say
Yes,
that
sir.
this is ionic. The chlorine is more electronegative than potassium. Therefore, I can assign a number of +1 to potassium and -1 to chlorine. Therefore, I say the oxidation number of K here is +1 and Cl is -1. Got it?
Yes, sir. Got it.
So if CH4 is covalent compound, but I assume it is ionic, student, I assume it is ionic, and the electronegativity of carbon is more than hydrogen, slightly more than hydrogen. So what we say that hydrogen is, in this case, what happens? The oxidation number of hydrogen, if there are four hydrogen, for one hydrogen it is +1. Then what will be for carbon? Then carbon will be what? There is one carbon and four hydrogen. So
Yes, sir.
+1 into 4 will be +4. +4. So for hydrogen, there is how much? +4. +4. If we assign the oxidation number, then carbon will get how much? Carbon will be -4 in this case, because the compound you can see is neutral. This compound is neutral. There is no charge on it. So if one hydrogen is +1, four hydrogen will be +4, then carbon will get an oxidation number of -4. Carbon will get an oxidation number of -4. So we will assume that the compounds are ionic, and we give negative to the more electronegative element and positive to the less electronegative element. Number one, You have understood. Number two, I am saying.
Yes, sir.
Number two, I am saying most electronegative atom in molecule. Most
Okay.
electronegative element. ठीक है? Most
Yes, sir.
electronegative element, student, in a molecule is negative. What we are
Okay.
saying, more electronegative is assigned negative, is assigned student negative oxidation number, is given negative. These are the rules which we will be using for finding
So
oxidation number.
if the
And
specific element has higher electronegativity,
then will be given a
then it will
negative
be negative.
oxidation. We are going to take many examples to show you all this. ठीक है? And
Yes, sir.
will be signed negative oxidation number. Will be signed negative oxidation number. That will be given negative oxidation number. ठीक है? And how many electrons it need to gain? ठीक है? That will be the oxidation number. Uh, how many electrons? How many electrons it needs to gain? It needs to gain, because the more electronegative element is gaining the electron, more, how many electrons it needs to gain, ठीक है, to have a full outer shell, to have full outer shell. We will give you example of that. For example, supposing I have H2O, ठीक है, in H2O, tell me which is more electronegative, oxygen or hydrogen?
In H2O,
Oxygen is
O
more
is more.
electronegative. Now, how many electrons oxygen need to complete its octets? You know what is the electronic configuration of oxygen? This is oxygen atomic number is 8 and it is 2 6. It needs 2 electrons. If I get 2 electrons, it will become 2 8. How many electrons oxygen needs? Tell me. 2.
6, 2, 2.
6 plus 2 will become 8 now. So it needs
Yes.
2 electrons, student. So the oxidation number of oxygen is -2 in this case. How much? -2. And if it is -2, the total compound is neutral. Then each hydrogen is +1. The oxidation number of hydrogen is +1. The oxidation number of oxygen is -2 in this case. Understood? More electronegative element gains the electrons. ठीक है? How many it will gain? If it has 6 electrons in the outermost, it will need 2 electrons. So it will take the 2 electrons from hydrogen, because
Yes,
hydrogen
sir.
is less electronegative. Then hydrogen will become +1. There are 2 hydrogens. How many are there? 2. So there are 2 hydrogens and 1 oxygen. This is -2. Then this should be +1 and this should be +1. Okay. So the oxidation
Yes,
number of
sir.
hydrogen is +1 and that of oxygen is -2. Clear?
Yes, sir.
These are rules which we are using, student, for assigning the oxidation number. So assign oxidation number according to the overall charge on molecule or ion. देखो, there is some overall charge on ion. If there is an ion, there is an overall charge. We have to take the sum of the oxidation number, ठीक है, and the coefficient equal to overall oxidation number of the molecule. For example, if we have to take overall charge of the ion, if I write CO3 2 minus, ठीक है, this is ion, students. This is the ion. Tell me how much charge is there? 2 minus. You know carbonate ion.
Yes, sir.
It is obtained from H2CO3. What did we say? 2H plus and CO3 2 minus. Now there is 2 plus. ठीक है? Now in this case, if I have to find the oxidation number of carbon, student, then I have to add the oxidation number of this. This should be equal to 2 minus. Carbon, supposing carbon is X. ठीक है? Oxygen oxidation number, how much you got? -2. How many are there?
Yes, sir.
3 into minus 2. This must be equal to minus 2. Then what will be the value of x? Calculate. What is the value of x, student? Calculate.
Wait,
So
value
you
of
have to
X,
assign
it
oxidation
is the,
according to overall charge on the molecule or ion. Assign oxidation number according to overall charge on the ion, taking into account sign and coefficients. ठीक है, sign and coefficients of all the elements which are present in it. What is the value of x?
X is minus 6, and then
X minus 6 is equal to minus 2.
minus 2,
Then what is x?
then minus 2 divided by minus 6. Sorry, so, oh wait, sorry, it was
Plus 4.
plus 4.
The carbon oxidation number here is how much then? This is the oxidation number of carbon. What is x? X is the oxidation number of carbon, student. What is the oxidation number of carbon here? Plus 4.
Plus 4.
So we have to work out the oxidation numbers by the rules which we are saying. And fourth rule I am saying, the oxidation number of atom in an element is 0. Oxidation number of element, ठीक है, oxidation number of atom in element is 0. What it means? If I say Cu, it is an element.
Yes, sir.
If I say Mg, it is an element. If I write Fe, it is an element. If I write Ag,
Yes, sir,
and
it is.
this, what is the oxidation number? This is their oxidation number is 0. How much?
0.
0. There is no charge. Did I write any plus or minus? No.
No, sir.
So the oxidation number is equal to 0 in these cases. If I write O2, there are 2 oxygens. That's all.
Yes, sir, there are 2
Oxidation number
oxygens.
0. If I write H2, 0. H2 is made up of 2 hydrogen atoms.
Yes, sir.
If I write N2, 0. So here both the atoms are same. You can see that both the atoms are same. Student, there is no positive or negative. There is no ion in this. Possibility not here. There is no possibility that one nitrogen is positive, other is negative, because both are the same atoms.
Yes, sir.
So therefore, the oxidation number 0 in such cases. In such cases. And further, we are saying, if I take group 1 elements, students, elements, can you name some of the group 1 elements? Which is
Group 1
in the periodic
elements will
table?
be
Alkali metals.
alkaline metals.
Which are those?
Sodium,
Sodium, potassium, all these. ठीक है? They have an oxidation number of 1. So their oxidation number is plus
1.
They are in group 1, their oxidation number, and usually you know the metals lose electron. They lose electrons, so plus 1. What will happen? So when I will write their oxidation numbers are group number. Oxidation number means in their compounds. What do you mean in the compounds? Student, oxidation number will be given in the compounds, not in the element form. No, not in the element form. Got it? If it is element,
Yes,
it is 0. For example, if I write NaCl, it is a compound. This is group 1, so it will be plus. And this will
yes,
be
sir, it will be.
plus 1 and minus 1. So their oxidation. And for group 2, the oxidation number will be 2. The oxidation number will be 2 for group 2. That will be plus 2. For example, if you write calcium chloride, this is group 2 element. Magnesium fluoride. This is group 2 element.
Yes, sir.
Here calcium is plus 2. Magnesium is plus 2. These are the oxidation numbers. The maximum possible oxidation number for an element will be its group number, will be its group number. And another important point we want to tell you, okay, can I, you have noted this, then I will rub it.
Which I'm noting it down.
Okay, note it down. If after you note it down, you will tell me, I will rub this. These are the
Okay,
rules
sir.
we have to learn, students. Then we will start doing questions on this.
Okay, sir, written, sir.
Okay. The oxidation rules have to be learned, students, so that we can then further proceed for the reactions where we will find out which is being oxidized, which is being reduced by using the oxidation number. The questions will be there. They are very important. This helps us in understanding the reactions, because in chemistry, in the reactions, you will find there is a transfer of electron, and we can use oxidation number ideas for these reactions. Actually, rules, when we say these are the rules, as we will solve questions, then it will become more easy. Then we will start knowing. Just as oxygen, I am saying most of the time -2, but there will be exceptions. There will be other oxidation numbers also. Hydrogen, we are giving +1. So there will be exceptions to the oxidation number, which we will learn. First group
Okay.
element, you are saying they are metals. Metals lose electrons, so they are getting +1 oxidation state. The second group element, you are saying they are getting +2 oxidation state. Like this, we can assign oxidation number, students, and then we will see. Further, I'm saying, what I'm saying, the sixth point I'm saying, student, the maximum possible oxidation number. Maximum possible oxidation number is nothing for group 1 and 2. For group 1 and 2, it is their group number. Group number. First group, for example, you are saying group 1. What is their maximum oxidation number? Only 1. Maximum oxidation number, only 1. For group 2, maximum oxidation number, this is the maximum oxidation number. Only 2. Okay? +2.
Yes, sir.
But after you are coming in the periodic table, you have seen, then we are having group 13 to 14, 15 to 18. These group numbers on the right hand side, on the right hand side. Okay? And you will, what you will do? Group number -10. -10. Okay? That will be the maximum possible oxidation number. But I'm trying to give you maximum possible oxidation number. For example, for group 13. Group 13, what I will do, 13 minus 10, how much? 3.
13 minus
The
10.
maximum oxidation number. And you know which is group 13? Boron, aluminium, gallium, indium, thallium. So what will be their oxidation number? You know, for aluminium, maximum is +3.
Yes, sir.
13 minus 10. For group 14, what will you get, students? 14 minus
13 minus
4. So carbon, silicon, germanium, tin, lead. This is 14th group.
Yes,
Carbon,
sir.
what is the possible? +4 maximum.
+4.
For group 17, for group 17 minus 10, 7 will be the maximum oxidation state. 7 will be the maximum oxidation state for group 17, which are the halogens. Halogens. Similarly, we can find the oxidation number. Oxidation number, if I have group 16, what will happen? Which is group 16? Oxygen, sulfur, serine.
Oxygen, sulfur.
So what is 16 minus 10? How much?
6.
So they have maximum of plus 6 oxidation state.
Yes, sir.
Maximum of plus 6 oxidation state. So
They can have less than they can have
because
5
there
4.
are students, there are only 6 electrons in their outer valence shell. In their outer valence shell. That is why. So there are only 6, so they can be only plus 6. So plus 6. For example, if I take carbon atomic number is 6. 1s2, 2s2, 2p, 2. Okay? This is the outer
Yes,
shell, outer valence shell. Yes or no? How
yes,
many
sir.
are there total maximum electrons? Tell me. 4, 2 plus 2. How many? 4. Maximum. So maximum oxidation state it will show will be plus 4. Got it? So the outer valence electron in carbon is how much? This is a filled inner one, 2s2, 2p2. That is the reason. Got it? Do you understand, students, or any doubt?
Yeah,
If
I
you have
understood,
doubt,
sir.
you will let me know. If you have doubt, you will let me know, students, how we are giving and assigning oxidation numbers. Rules have been made by using some logic of chemistry. Rules cannot be made blindly. Any doubt here?
No, sir.
Okay. All right, you understood up to now. Then we will proceed further. You can note down, meanwhile, all the information is very, very important, student. How we are calculating oxidation numbers. The recorded videos will be available in case of any doubt. You can see them, watch them, share it with your friends. Ask them to subscribe because we will uploading very, very vital information. In case of doubts, you can always listen to these video, students, and see how to calculate the oxidation number by using the rules. We are teaching you all the rules today. Then we will start working on the reactions. Okay?
Yes, sir.
Okay, very good. Very important concept of chemistry. Very, very important concept of chemistry, student. So we are saying in general, you see, if you have a, I can say further, I can say that if you have a, you see, if fluorine is an atom, if the charge on the fluorine is F minus, it is F minus, then the oxidation number is -1.
Yes, sir.
-1, no problem here. If I
Yes,
am
sir.
saying, but I am saying that whatever is the ionic charge, because fluorine is highly electronegative.
What?
Fluorine is highly electronegative.
No.
So highly electronegative. Fluorine halogens are highly electronegative, students,
Yes, sir, they are.
because fluorine is the most electronegative. It will always get, fluorine will always get how much? -1. Why? Because it is the most electronegative element. Fluorine cannot be plus, always -1. And if I say oxygen is the element, you are saying oxygen is 2, 6. It needs 2 electrons. So what it will do? You are saying O2 minus. So what then oxidation number will be what? Oxidation number of oxygen is -2, -2. But in some compounds, note down, in some compounds, for example, if oxygen forms compounds with fluorine, if O2F2 or OF2, what happens? Fluorine is more electronegative than oxygen. Fluorine is more electronegative than oxygen. Here oxygen will become plus. So in this case, oxygen is +2, student. In this case, oxygen is -1. Oxidation number. Got it? Exceptions. There are exceptions also. So when oxygen is joined with more electronegative element, it can be +1. This is +1. This is +2. It can be +1 or +2, and also in peroxides.
Okay.
And Na2O. Here, what is happening? This is +2, this is -2, no problem, no problem. But if I write something like lithium, uh, lithium oxide, okay, potassium. If I write and sodium, lithium, sodium, potassium, if I write K2O, students, what will be the charge here? K2O. Or there can be peroxides also. Peroxides like HOOH. This is a oxygen linkage. This is +1. This is -1. This is -1. And this is +1. See, peroxide. These are called peroxides. Hydrogen peroxide. Here oxygen is -1. What is the oxidation state of oxygen? -1. In this, what is the oxidation number? You have potassium +2. Potassium is +1. So this is potassium is +1, student, +1. Then what will be the oxidation state of this? So if I put +2, x equal to 0. X is equal to -2, no problem. But if I have in this compound KO2, potassium superoxide. This is a superoxide. Potassium is +1.
Yes, sir.
Then oxygen is, there are two oxygens, +2x equal to 0. So what is the value of x? -1/2. Here the oxidation number of oxygen is -1/2. See, there are certain exceptions which we have to learn. Okay? Further, I am talking about Cl, student. Cl -1, but if Cl is attached with oxygen and fluorine, but Cl with oxygen and fluorine, then this is possible to have +1, +3, +5, and +7 oxidation state. Note down, chlorine is -1 except when attached with oxygen and fluorine. Why?
Okay,
because oxygen is more electronegative than chlorine, and fluorine is more electronegative than chlorine. It can be +1, +3, and +5, and +7. Noted?
Yes, sir.
Okay. Hydrogen, we are saying, hydrogen is usually H+, means +1. Hydrogen is +1, but in hydrides, what we call as hydrides, in metal hydrides, student, metal hydrides I am saying. What are metal hydrides? For example, if I write NaH, sodium is a metal.
Yes, sir.
It will give the electron. Then hydrogen will become what? Sodium is +1 oxidation number. What will be the then oxidation number of hydrogen? -1. So hydrogen is +1, but if it is attached with metals, then it will become -1. Students, it will become -1. Yes or no? Tell me.
Yes, sir.
Do you have any doubts, student, here?
No, sir.
So here, what we have been teaching you is how to assign oxidation number to the elements, and by using the rules which we have told you. So maximum oxidation number for group 1 is +1. Maximum oxidation number for group 2 is +2, students. And maximum oxidation number of group 13 is +3. We have shown it. here, and maximum oxidation number for group 14 is +4. And for group 16, how much? Maximum
Uh,
oxidation.
+6,
And for group 17,
+7.
so there is a connection between group number and maximum possible oxidation number, students. Okay? So
Yes, sir.
I hope you have understood how to calculate the oxidation number by the rules which we have to do. So in this lecture, we have given you the rules in order to find the oxidation number. Do you have any doubts, students?
No, sir.
Okay, then we will meet you in our next lecture. Continue more about this. This is a new chapter which we have started, and we will try that the basic concept should be clear, students. And if you have doubts, you can watch our video YouTube and subscribe it, and also share it with your friends, because we are working very hard for you people. I'm working very hard so that I should be able to explain all the chemistry and decode your books completely. That is my point. I hope you will appreciate my hard work, and I will thank you for interacting with me, and we will meet you in our next lecture. Okay, then, good night. Good night, students. Any doubt?
No, sir.
Okay, good night.